Hi everyone, my name is Adil and I am from S1 BSc Computer Science. Today I am going to present a seminar on the transformative technology in modern computing, edge computing. In the era of the Internet of Things, AI and the real-time analytics, enormous amount of data are generated every second. Traditional computing, which send all this data to centralized servers for processing, often faces challenges such as high latency, bandwidth, and constraints the delayed response. This is where edge computing comes in. Edge computing is a distributed computing model that processes data close to the source, whether it's sensor, a smartphone, or a smart machine. By moving computation to the edge of the network, it enables faster decision making, reduce data transmission cost, and support real-time application. Applications like smart traffic management in cities, autonomous vehicle, remote healthcare monitoring, and industrial automation heavily on this approach. Essentially, edge computing bridges the gap between raw data generation and intelligence action. Edge computing can be defined as computing that brings computation and data storage closer to where it needed. By handling data locally rather than sending everything to the cloud, it improves response times and conserve network resource. How data edge computing work? The process work as follows. First, device like sensor and IoT device gadgets collect raw data. Next, this data is processed locally at nearby edge server or gateways. Finally, only the important or summarized data is sent to the cloud for storage and further analysis. This approach reduces dependency on the cloud and enables faster, more efficient decision making. The architecture of edge computing has three main layers. The first layer is edge devices, which includes sensor and IoT devices that generate data. Second, edge nodes or gateways, which process and analyze the data locally. Third, cloud data centers, which are used for long-term storage and large-scale analytics. These three structures ensure smooth data flow from the device to the cloud with minimal delay. Key components of edge computing include IoT devices and sensors, edge servers or micro data centers, networking, the communication system, and software platform for management data or data management. Advantages of computing. Edge computing serves several important features such as low latency and real-time processing, centralized data handling, enhanced data privacy, security, and reliable performance even under poor connectivity conditions. The advantages of the edge computing includes reduced latency, data processed locally, instant response, lower bandwidth usage since less data is sent to the cloud, improved reliability, allowing system to function even during internet outages, and enhanced privacy, keeping sensitive data on locally device or network. Challenges. Despite its benefit, edge computing faces challenges. Managing multiple edge nodes can be complex. Security risks exceed its local processing points. Edge devices have limited storage and computing capacity, and thus an initial setup and maintenance cost can be high. Edge vs cloud computing. While cloud computing relies on large remote servers, edge computing brings processing closer to the user. Edge is ideal for real-time critical operations, whereas cloud computing excels at large-scale storage and analytics. Together, they form a hybrid system for optimal performance. Future of edge computing. The future of edge computing is extremely promising. With the rise of 5G network and AI, edge computing will be essential for real-time analytics. automation and intelligent systems in industry, smart homes, and autonomous transport. To conclude, the edge computing represents the future of distributed data processing. It enhances speed, efficiency, and security while reducing latency and network load. As IoT and AI continue to grow, edge computing will transform industries and become a core part of modern digital infrastructure. Thank you for your attention.